We're beginning it today, this first idea of talking about what are vectors. So let's define them, let's use them. Okay. They are used for us in geometry to describe translations. So they're a way that we can use them to describe translation. That's one thing that a vector can do, right? And a vector has two parts. Has two parts to a vector. Here are the two parts that we got to be aware of. Number one, it has a direction. So you have to know which way you're going to move something in the plane. And the vector, one of the parts of the vector will tell you that. Is it up and to the right? Is it down to the left? Is it straight up? Is it straight left? We're talking about translations here. So we're talking about sliding things around. So the direction is important, okay? The other thing is, once you know the direction you have to go, you want to know how far you're going to go in that direction. So we have direction and we have magnitude. Now, magnitude is just a fancy word for length. 7 units in the positive y direction. So draw our coordinate grid here. Let's go 6 units in the x direction. And let's go 7 units in the positive y direction. One, two, three, four, 5, 6. 1, 2, 3, 4, 5. And there's 6. Okay, please put a point in your coordinate plane at 1, 1. And call that point P. So 1, 1, call that point P. Let's go over to 6, 5. And let's call that point Q. 6, 5, and call that point Q. Okay, so I've got 2 points in the plane, P and Q. Let's draw an arrow that goes from P all the way to Q. All right? And notice the way that I've drawn that arrow, right? How do I know there's something that gives it away? How do I know that this arrow goes from P to Q and not the other way around? Yeah, Allie. Yeah, it keeps getting positive, but there it is. That's a good point. What else do we have? Yeah, the arrow, right? The arrow tells us that it goes from P to Q. So that means that P has to be the initial point. That means P has to be the initial point. And Q has to be the terminal point. So we have an initial point, we have a terminal point. And the way that we describe vectors now is like this. We say PQ, so going from P to Q, where P is the initial point and Q is the terminal point. Then we put a little line with a little tiny arrow backwards. So that represents vector PQ. So vector PQ is represented like that, with a little hat that goes backwards. Yeah, half an arrow, right? Okay, now here's the important part. We're going to break this down, right? Vectors have two components. Vectors have an x component and a y component. The x component is just how many spaces you have to move to the left or the right, and the y component is how many spaces you have to move up or down. So the x component of this vector would be, let's count with them. So going from P to Q is 1, 2, 3, 4, 5 units, right? So the first component of vector PQ is going to be a 5. Now I count how many units up I need to go to get the y component of my vector. So that's going to be 1, 2, 3, 4. So I need to go up, looks like 4 units. So the y component is 4, and this is how we describe vectors in the plane. So vector PQ has components 5, 4, which means that I go for every 5 units to the right, I go 4 units up. And that gives me a direction and a magnitude, which are the two parts that I need to find their components. Okay? So, give yourself 3 examples here. A, B, and C. A, B, and C. Set up A, B, and C right now. And what we're going to do is we're going to draw a coordinate plane for each one. And let's say you have to go just 3 units in all directions. For x and y, 3 units in all directions. X and y. X and y, 3 units in all. 3 vectors here. 3 vectors, A, B, and C. All of them are going to be vector AB. I would like you to break down their components and write their component form for A, B, and C. Use the people in your group, bounce ideas. People are struggling with this. So let's do it together. Daisy, what did you get for part A? Figuring out those vector components. Yeah, let's see here. Okay. So here's how you write this, everybody. AB is equal to, it's going to have, okay, so here we go. Back to our point here. Vector component AB. We have to break this down. So you got to ask yourself, how far do you have to move in the x direction? You got to go 1, 2, 3, 4, 5. So we have to go 5 in the x direction. We need to go 1, 2 in the y direction. So the 5 represents the x component, and the 2 represents the y component. So 5 to the right, 2 up. So vector AB is 5, 2. Mandy, what did you get for B? I got AB with the little line of it, and then the equals 0, 5. 0, 5. So we say vector AB has components 0, 5. AB has components 0, 5. Okay, Lalo's group, what did you get for part C?
Vector AB equals components 2, -1.
Yeah, 2, and then negative 1, 2, 3, 4. So 2, -4. So it has the components 2, -4. Okay, you guys feeling pretty good about vector components now? Okay, let's use them in our last box here, box number 3. Okay. Please draw a pretty decent sized grid here. Let's go 4 units. Okay. Gonna give you a triangle. Put the coordinates on that triangle. So we're gonna give you point 0, 0. Call that A. 4, 0. We're gonna call that B. And 1, 3. We're gonna call that C. And we're going to draw a triangle ABC. Okay, we want you to translate triangle ABC along vector GH, which has components -2, -1. Yeah. Okay, so think about it this way, right? You can translate every single point along vector GH, which has components -2, -1. So if I, for example, start at A, if I go -2, -1, this would be my vector, right? Would you guys agree with that?
Yeah.
So that point moves to there. How about C? If I start at point C, I go back to 1, 2, and down 1. So right there, that's another vector that has components -2, -1. And then if I try vector B, right, I go back 2 and down 1. So my new components are staring at me in the face, right, after I've translated it. So now that triangle has been translated along vector GH, which has components -2, -1. So each one of these represents vector GH. GH vector, GH vector, and GH vector. Does that make sense how I did it?